Welcome to the Beginner's Guide to AI with your host, Professor GePhardT. Today, we delve into the fascinating world of deep learning, a revolutionary approach within the realm of AI that draws inspiration from the very structure and function of our brains. Imagine a system that learns much like how we do, starting from the basics and building up to complex understanding without explicit programming. That's the core of deep learning. Deep learning, a subset of machine learning, is not merely about programming computers but about teaching them to learn from the data they process. This approach uses artificial neural networks with numerous layers, mimicking the human brain, to learn hierarchical representations of data. These networks are capable of discovering intricate structures in large datasets by using the backpropagation algorithm to indicate how a machine should change its internal parameters that are used to compute the representation in each layer from the representation in the previous layer. The significance of deep learning lies in its ability to process natural data in their raw form. For instance, traditional machine learning techniques like logistic regression and SVMs often require careful feature engineering and considerable domain expertise to craft an input detector or classifier to perform well. In contrast, deep learning systems automatically learn the features and tasks directly from data. This eliminates the need for manual feature engineering, which has been a bottleneck in traditional machine learning approaches. Deep learning's capability extends beyond just automating tasks that are easy for a human to perform, such as identifying objects in a photo. It's also superb at managing complex problems like interpreting medical images, making sense of time series data for financial predictions, and understanding human speech, often performing at levels comparable to and sometimes exceeding human experts. These models are constructed with layers stacked upon each other, each layer learning to transform its input data into a slightly more abstract and composite representation. The deeper the layers, the more complex the features that the network can understand, making it possible to handle very sophisticated tasks. Its power and scalability make deep learning a cornerstone technology driving many modern AI applications, pushing the envelope on what machines can achieve. However, this power comes with a set of challenges and considerations, including the requirement for large amounts of labeled data, substantial computational resources, and the need for fine-tuning to avoid issues like overfitting, where a model might perform well on training data but poorly on unseen data. By the end of today's episode, we aim to demystify the technical complexities and highlight the transformative potential of deep learning, providing you with a robust foundation to appreciate its impact and the ethical considerations it brings to the fore in various sectors of technology. Stay tuned as we explore a practical case study in the next segment, illustrating how deep learning is applied in the real world to solve problems that were once thought to be the domain of human cognition alone. The intricacies of deep learning, unveiling the core of AI's learning abilities. Deep learning, at its essence, is a fascinating blend of computational prowess and inspired design, mirroring the layered complexity of the human brain. Let's dive deeper into this core concept of AIs. Starting with the basics, deep learning is a type of machine learning that utilizes layers of algorithms called neural networks. These are not just any algorithms, but ones structured in layers that resemble the human brain's neural architecture. Each layer is made up of nodes, and each node is like a miniature detective, making its own little observations about the data it sees. As data passes through each layer, the network learns to recognize different aspects of the data, starting from simple features at the lower layers to more complex abstractions at higher layers. One might wonder, how do these layers work? It's all about transformation and learning. In the initial layers, the network might learn to recognize edges and colors in an image. In deeper layers, it combines this information to recognize more complex structures like shapes or specific objects. This hierarchical learning approach allows deep learning models to learn complex patterns efficiently. What sets deep learning apart from other machine learning methods is its ability to perform feature extraction automatically. Traditional methods often require human experts to define what features to look for, which can be laborious and limited by human imagination and bias. In contrast, deep learning learns these features directly from the data, continuously improving as it is fed more data. This capability is powered by a method known as backpropagation, essentially a way for the network to adjust its internal parameters based on the error rate of its output, refining its accuracy over time. Deep learning's strength lies in its versatility and depth. It's behind many of the sophisticated technologies we use today, from facial recognition systems and AI assistants to advanced systems that diagnose diseases from medical images. Each application relies on deep neural networks that can sift through and learn from vast amounts of data. Despite its impressive capabilities, deep learning is not without its challenges. It requires substantial data to learn effectively, without which it can struggle to make accurate predictions. Additionally, because it learns from data, any bias in that data can lead to biased outcomes. Furthermore, deep learning models are often described as black boxes because their decision-making process is not always transparent, making it difficult to interpret exactly how decisions are made. In this segment, we've explored what deep learning is, how it works, and why it's a transformative force in the AI's landscape. By understanding these fundamentals, listeners can better appreciate the next discussions on real-world applications and ethical considerations as deep learning continues to evolve and reshape our interaction with technology. Real-world application of deep learning, the case of autonomous vehicles. In this segment, we explore a compelling case study that illustrates the power of deep learning in a real-world application, autonomous vehicles. This example will help solidify our understanding of how deep learning principles are applied to solve complex problems. Autonomous or self-driving vehicles are one of the most high-profile applications of deep learning technologies. These vehicles are equipped with a myriad of sensors, including cameras, radar, and LiDAR, which collect massive amounts of data about the vehicle's surroundings. The heart of an autonomous vehicle's capability lies in its ability to interpret this data, make decisions, and learn from new experiences, tasks at which deep learning excels. At a basic level, deep learning models in autonomous vehicles are trained to recognize and categorize objects in their environment. This includes distinguishing between different types of objects such as pedestrians, other vehicles, traffic signs, and road markings. The ability to accurately identify these objects and predict their future positions is crucial for safe navigation. Deep learning further enhances the vehicle's capability by enabling it to make real-time decisions. For instance, when an autonomous vehicle encounters a situation where a pedestrian suddenly crosses the road, the vehicle's deep learning model can quickly calculate the potential paths and velocities of the pedestrian and adjust its speed or change its path accordingly. This decision-making process is underpinned by the vehicle's ability to learn from vast amounts of driving data, improving its reactions and predictions over time. An interesting aspect of applying deep learning in autonomous vehicles is the use of convolutional neural networks, CNNs, a type of deep neural network that is particularly good at processing data that has a grid-like topology, such as images. CNNs are used to interpret video data from cameras around the vehicle, providing a dynamic 360-degree view of the environment. This allows the vehicle to navigate complex traffic situations by understanding the context of its surroundings, like distinguishing between a stationary car and a parked one. Training these deep learning models requires large datasets of driving conditions, which often come from real-world driving hours combined with high-fidelity simulation environments where virtual scenarios, including rare or dangerous situations, can be recreated safely and repeatedly. This helps ensure that the vehicle is well prepared for almost anything it might encounter on the road. Despite the advancements, the deployment of autonomous vehicles powered by deep learning faces several challenges. These include technological limitations, such as how the systems perform in varying weather conditions, and ethical and regulatory considerations about responsibility and safety in the event of malfunctions. This case study of autonomous vehicles not only shows the practical applications of deep learning but also highlights the ongoing need for improvements and innovations. As these technologies evolve, they continue to push the boundaries of what machines can achieve, promising a future where autonomous vehicles could become a common sight, reshaping our transportation systems and daily lives. Join the journey into AI. We hope today's episode has sparked your interest and deepened your understanding of deep learning. To keep learning and stay updated with the latest in AI, we encourage you to subscribe to our newsletter at argoberlin.com/newsletter. Here, you'll find valuable tips and tricks for beginners, along with insights into how AI is evolving and impacting various sectors. Don't miss out on this opportunity to be part of a community that's at the forefront of AI exploration and learning. Interactive exploration of deep learning. To further engage with the topic of deep learning, here's an interactive element for you. Reflect on the case of autonomous vehicles and consider how deep learning contributes to the functionality and safety of these systems. As a deeper exploration, I encourage you to read the latest research papers on convolutional neural networks, CNNs, which play a crucial role in processing visual information for autonomous driving. Additionally, experiment with a simple AI-based tool, such as TensorFlow or a similar platform, to get hands-on experience with neural networks. This will provide a practical understanding of how deep learning algorithms function and are applied in real-world scenarios. Recap of today's dive into deep learning. In today's episode, we ventured into the intricate world of deep learning, a pivotal technology in the field of AI that mimics the layered complexity of the human brain. We began by unpacking the fundamental concepts behind deep learning, highlighting its ability to automatically learn and improve from vast amounts of data without the need for manual feature engineering. We then explored a practical application through the case study of autonomous vehicles, demonstrating how deep learning enables these machines to interpret complex environments and make critical decisions in real time. This example not only illustrated the capabilities of deep learning but also touched on the challenges and ethical considerations involved in implementing such technologies. Through this discussion, we've seen how deep learning stands at the core of many modern AI applications, driving innovations that seemed like science fiction just a few decades ago. This episode has laid a foundation for understanding the profound impact deep learning continues to have across various sectors, from healthcare to transportation. A lasting thought to carry forward. As we conclude today's episode on deep learning, let's reflect on a quote from Geoffrey Hinton, a pioneer in the field. "Deep learning is going to be able to do everything." This statement encapsulates the vast potential and the transformative impact deep learning holds within the realm of AI. Remember, the journey into AI is ongoing and ever-evolving. If you enjoyed today's deep dive into deep learning, don't forget to subscribe to the podcast for more insightful episodes. Together, let's continue exploring the vast and fascinating world of AI.